Hello there, YouTubers. Welcome to another video. As we know, JavaScript has been around for a long time, and if you're new to JavaScript, you might hate it. You might like it right off the bat, but who knows? Most of us go through phases where we learn a little bit about it, make a bunch of mistakes, learn to hate it, learn some more, eventually master it, and then learn to love it. And the reason for that is because JavaScript is so different than most other static object-oriented programming languages, and it's quite a challenge to learn. So here are 10 ways that JavaScript is different than your favorite static OOP language. So let's get started. Starting with number 1, types can change. In JavaScript, you're not bound to one particular type when you declare a variable. In fact, you don't declare a variable type when you declare it. So types can change. Let's take a quick look. As you may be aware, JavaScript has only a few types. Java has strings, it has number, it has, and let's comment this out, has string, number, boolean, null, undefined, and symbol. So, but variables in JavaScript you declare simply with var, or in the newer versions of JavaScript, starting with ES6 and ES 2016, you have let and const. These are the preferred ways right here. You should always be using let and const if you're doing if you have access to ES6. If you don't, then that's when you would use var. var has some complications, but in order to be backward compatible, you don't have that. So, but the topic is types can change. So what do I mean by that? So let's say that I have a variable, and let's call it age. And in age, we store a number. And let's just log that. And when we log that, we get 21. Well, let's say that later on we decide that we don't want age to be a number anymore. We want it to be a string. And you notice that now age is a string, so the type changed. And JavaScript does have types. As we can see here, if we console log using the type of operator, or type of function, we can do that, and then we can do it down here after we change it. Let's run it again. Clear and run. So as you can see, the first time the type of is number, and the second time it's string. So that's number 1. Number 2, objects are maps. So what does that mean? Well, you may be used to maps in your favorite programming language. And in JavaScript, objects are really just maps. And well, that's the only one facet. That would be oversimplifying objects. Objects are much more than that. But one facet of them is that they are maps. Let's take a look. I can declare an object by simply saying, let's just say person, and this person has properties. So for example, first name, and last name. And let's say that he has an age. One way to access the properties of this object is to simply access them using the dot operator, as you may be used to in your favorite programming language. Let's go ahead and run that. As you can see, we have Joe Smith and he's 21, and you don't see the string literal, so because that's the age. So, but there's another way to access properties within an object, and that is like this. Let's say we took all this same information and we accessed it like this. And as you can see, I get the same results. We can clear it and run it again. You'll see that we get it twice. And that is because an object can be used as a map. And in essence, it is sort of a map. Let's say that, for example, you did have a map of things and you wanted to have a map where you had certain properties. And let's just take this person. Let's just call this map in this instance. Map. And you have key value pairs. So let's say in this map that you wanted to store dictionary entries. So let's say that you said map and you said dog and you set a definition to it. And then we can simply access them like this. And as you can see, we get the same results. But what about this one? I'll leave that up to you to figure out how you can access that. But the only way that you could probably access that would be like this. I'm not sure that you can access it any other way, just other than using the quotes. In that case, as you can see, you can still store it, but the only way you're going to be able to access that property is literally by using the bracket operators. So that is one way that JavaScript is different, because objects are essentially maps. That's not all they are, but that is one thing they are. Number 3, arrays in JavaScript have superpowers. What do I mean by that? Let's take a look. So let's declare an array. So as you can see, I've declared an array here. And what I've done in the array, I've added some types. So the first thing is that you may notice is that I declared the array and I declared all these different types. Here I have a string, a number, a boolean, and even a function. And I think I'm missing a bracket. So let's add our bracket. So now I can access the items in the array. So one of the first superpowers is the array can store any type, and it can even mix types. So let's display this array. See if this runs. And as you can see, we have all our types lined out. And the function, you notice that it lays out what the function is, but we can do one additional thing. We can actually execute that function. And arrays is zero index, just like your favorite programming language. So 0, 1, 2, 3, 0, 1, 2, 3. Okay, so it's the third item. It's, well, the fourth item, but the index 3. So let's call our function there. Let's clear and run again. And you notice that it executed the function. So that's one of the powers, that they can have different types. And really any type, other objects, other arrays, anything can go in there. So that's one of the superpowers of the array. Another superpower of the array in JavaScript is that you don't even need other data structures like you do in C# or Java. for example, because you don't need math, you don't need, well, not math you would need the object, but you don't need necessarily lists and all these different things that you normally need in other languages. And that is because the array can grow and it can shrink. So let's take a look at that. So if I wanted to remove the items from the array, well, let me leave that. Let me go back to this. Let's say that I removed an item. Let's remove the function. So I can pop items from the array. And this is going to remove them from the end. I could even store it if I wanted to. And I could log it or I could execute it or whatever. But I'm just removing an item. So let's go ahead and rerun it. And you notice the function is gone. Well, we can also add additional items to the array by simply calling. And we can push another item. So now we can push an item to the array. So there you have it. We added an item to the array. But those are only two ways to add and remove items. We also have shift and unshift. So let's take a look at that. And I'll talk about why that's important. So let's go ahead and take a look at shift and unshift. So, and I was getting mixed up. You might too, I don't know. So if I unshift an item and then I run it, let me see if I have this correct. You notice that now, let's go ahead and clear it. Let's run it. What is, okay, so I did unshift and it didn't do anything. So that didn't do anything, so it must be shift. So let's go ahead and take shift. And you notice now with shift that it removed the first item in the array. So shift is a way to remove an item from the array from the beginning of the array. You can also have, I believe there's a delete. Let's not get into that. But this is important because you can unshift, remove an item from the beginning, and you can also add an item to the beginning, and that's the unshift. And let's just call it number 1 and let's see if it works. And you notice that I removed the first item and I added the number 1 and now it has that. So shift and unshift. Why is this important? Well, in your other programming languages, you may have things like queues and stacks and so on. And as you can see, if you were to do a stack, for example, you can pop and push and your array will behave like a stack. Since you can store any type in the array, that means that you can use it for a stack of anything. So if you're trying to implement a queue, another way to implement a queue would be by shifting and unshifting. So you could actually shift, something to remove it from the beginning and you can push it at the end, or you could do it the other way. You can unshift from the beginning and always pop from the end. That'll behave like a queue. So that's why it's important. But there's more to arrays. Arrays also have many different capabilities. Among them are things like filter and map. So let's take a look at one of them. Let's take a look at map. So let's say that we wanted to map these items into something else altogether. Let's call this rows. And let's take our items. And I'm using older JavaScript here. You can also use newer JavaScript. You can use arrow notations, but in this case, let's just say we are doing this. And we are going to return items. Let's say that we wanted to take something like, put them in a list or something like that. And let's go ahead and copy this logic here, this for loop. Clear and run it. And you notice what it did. Starting here, you notice that I have number 1, 5, false, and everything. So essentially what I've done is converted my map. It's looped through my array and it's mapped the items, and I, modified each item by adding it to a list. So this is a really handy function that's built right out of the box. So that's map. There is also something called filter. And filter works a little bit different because you may want to actually filter out items that maybe you don't agree with or something. So let's just say that you are filtering. Say filter, and you can return if, you can execute an if statement. So you can say if item equals something, for example, number 1, return true. Otherwise, just return false. And what that does now, this is going to give us the rows only where that item is equal. So let's go ahead and execute that again. And you notice that this time it gives us only that. So let's get rid of this for now so we don't get it mixed up. And you can see what I'm doing. So you notice that it filtered out only the item number 1. Now you could have other criteria. For example, you may have something that starts with a certain letter or is uppercase or whatever you're looking for. You can do certain substrings or whatever you may be looking for and just return true or false. So that's the filter function. So you saw the map, the filter, but there's many others. So if you really want to take a look at all the capabilities of the array, just go ahead and go online to the official reference and you'll find everything you can do with arrays. But they're a lot more powerful. As you can see already here, we have length and items, and it can grow and it can shrink and it can have different types. So arrays are very powerful and leave very little need for any other type of your typical collection data structure. Number 4, JavaScript has more comparison operators. In your favorite OO language, you may be used to a certain set of equality operators and comparison operators. JavaScript has a few more because of something called coercion. Let's take a look. So in JavaScript, you have additional operators. Normally you're used to something like this for equality, and maybe even this, and this, and this, and this, less than or equal to, and greater than or equal to. But in JavaScript, you also have this, and this, and this, and so on. And the reason for that is something called coercion. So let's take a look at coercion. So if I say if 5 equals 5, you notice that that's true. But what if I did this? And let's just use a semicolon. What if I did this? Now it's false. And the reason for that is because this one, in this comparison, it coerces the value into an integer. So whatever this is, it coerces it into that. And so that becomes a 5. In this case, it first compares the types. This is number and this is string. They're not equal, so it doesn't even bother making the second comparison. So then that means they're false. And that works the same way for less than or equal to and greater than or equal to and so on. So you would compare them the same way, because if we say let's say let's clear it and run it again. You notice that this not equal this is false because they're actually equal, but in this case they're true, right? Because this is not equal to this, that means this is a true statement. And it would work the same way with all these other ones. So I don't think we need to go into that, but just know that you have additional operators, and that's due to coercion. The preferred method in JavaScript when you're comparing types is to use this approach. Number 5, functions are first-class citizens. Let's take a look. In other languages, such as Java and C#, you may be used to having to declare delegates or actions or functs or whatever other type to wrap itself around a function. But in JavaScript, functions are first-class citizens. That means that you can assign them to variables. So a function is simply this. There we have a function. But what if we wanted to do something different? What if we wanted to store that function in a variable? As you can see, I assigned a function to a variable and I passed it. Why is this important? Well, if you notice when we did the array section and we talked about arrays, you can see where the array had callback functions. So for example, let's say that I have another function that requires it. As you can see here, I'm calling mathop and I'm passing add into it. But mathop takes additional parameters, so let's add those parameters. And we didn't return the value. Let's return the value. Now we have 20. So this function waited till we execute it and then we can call it back. But we can also, since we can store the functions in variables, we can also do something like this. You can see we're executing the function. We're executing foo first, actually, and then the mathop. But sometimes where you have callbacks, you don't even have to pass a function. You can declare the callback right in place. So I can declare my function here, and I can have my X and my Y, or A and B, or whatever I want to call it. And let's just say return A plus B. And this time it should give me 9. And it does. As you can see here, I declared the function right in line and it returns that. So in JavaScript 6 and ES6 and in ES 2016, you can actually do something a little bit better than this, which looks a little bit cleaner because you have arrow functions. And so you can do it just like this, just like a lambda expression. And in actuality, you don't even have to do the curly braces since it's a single statement. And you can skip the return. And you can have that still. So let's try it again. It should do the same thing. And that's just another way to do it. So wherever you see a callback, you can actually have a lambda expression right in place. And that makes functions first-class citizens in JavaScript. Not only can you do that, but you can also add additional behavior, which I haven't really seen, and I haven't dug deep into the way a lot of frameworks are written, but you can actually extend a function and give it properties. Because when you actually look at the type of a function, let's say, for example, that I said, notice type of foo is a function, and type of foo is a function, but it is also an object. And I think I can do something like this. assign a value to it. And as you notice, it printed out the function. So I can extend the function just like I can any other object, but I have not really found the need for me to do it in my everyday programming. You may just know that you have that capability. Number 6, functions can be called with more or fewer parameters. In JavaScript, you can have a function that's declared with 1 or 2 or let's say 3 parameters, but it can be called with even 0 or 1 or 2 or 3 or even more. So let's take a look. So we have this function with these parameters, and we can use those parameters x and y, but what if we wanted to just figure out how many parameters we had and we wanted to extract them all and use them? So let's say, for example, we have this. As you can see here, even though we have undefined for the return because I didn't return the value, but it logged the length of the arguments. So what if I just return 0 for now? So if I wanted to access one of the arguments, I can simply say something like this. And as you can see, it output each argument 1, 2, 3, 4, and 5. Well, the first one in this case was 1. But what if I didn't call it with any arguments? You notice here I'm calling it with 1 argument at least. What happens if I don't pass it any arguments? Will it throw an error? Let's take a look. And it doesn't throw an error because the arguments is already part of the function. So it at least knows that the length is 0 and it won't go through the loop. So anytime you want to access the additional parameters, you could just say arguments. And again, I, in my personal use, have not found the need to use arguments, but I know that it is used heavily in frameworks because sometimes frameworks have to be dynamic in a way that they have to capture additional arguments or fewer arguments and things like that. So as you get deeper into it and you start building libraries or frameworks or anything like that, you may need to make use of this capability. Be aware of that because it's important, because if you call it with fewer arguments, you may get some weird bugs, and JavaScript will just keep trucking along and just let you get away with it until runtime, and that's when you have an error. So just be aware of that. That's another way that JavaScript is different, that you can call it with fewer arguments than declared or more arguments. It doesn't really matter. You may not have access to those arguments if you don't use the arguments keyword. So JavaScript has self-executing functions. That is number 7. So let's take a look. Another language you might be used to declaring a function and then somewhere later you call it. And you can do that essentially in JavaScript, but you can also execute the function right away. And in fact, you don't even have to name the function. So let's take a look at a function. So this function would typically be called by executing something, but since it's anonymous, I would have to assign to a variable or give it a name. But there's another thing I can do in JavaScript. If I wrap this function like this, I can actually execute the function. And this, because I'm declaring the function here between the parentheses and then executing it here, it will execute right away. So as you can see, it executes. Not only can I do that, but I can also insert parameters. So for example, here I have a parameter name, and let's just say that, and let's make use of something called, and this is a newer feature, and I'm using the backtick. This is by your tilde, typically on the US Windows keyboard. It's the backtick, and so we can use string interpolation, and this is a template, so let's just use name there. So hi there, and then it'll execute that. So let's take a look. Oh, it didn't execute it because, what am I missing? The $sign? I think so. There it is. Okay. So I'm missing the $sign. So it's executing the function. And this is something that becomes very important. You may wonder, why would you want to do that? Well, there are reasons why. And one of those reasons is that you may want to actually create some kind of singleton pattern, and you don't want that function to be called again. Since it's already being executed that one time, you can't really call it again. And let's say you were injecting, for example, something to some global variable, some global value, and it could only be done one time. So then it exists that one time, and it's called. And this is one of the techniques used for something like the singleton pattern, but it can be used for a lot more things. So just be aware of self-executing functions. Number 8, this is not always what you expect. In your favorite programming language, you may be used to the this keyword, and sometimes we totally take it for granted. We ignore it sometimes. We don't even use it within classes. And as you're going to see in JavaScript, it's not what you always expect. So let's take a look. In this example, you notice that I have this. And this, in this case, is referring to the global context. So the global context has a this already. So I'm making up a property. I'm just extending that object, the instance of that object, creating the variable x. I could have called it y, z, name, whatever. And I assigned a value a. Then I log the value. And I kind of gave it away, but we'll look at it again. So this x equals a, so I log it, and this x is going to be a. Now I have a person object here, and this is the way we declare an object literal. This is declaring an object literal, and this is just a simple way of saying this is a public method, and this is the definition of that method. And I have the function, it takes no parameters. I execute this .x equals a, which is a member of person, and I assign a to it. I then take foo, the function foo, declare it, because you can declare functions within other functions in JavaScript. And so I declare the function foo, and I assign this .x, I assign b to it. Then I execute the function foo, which is going to assign x to b, to this .x is going to assign b. So I call it, and then I return this .x. So let's take a look at what it does. In this case here, I'm calling the method person, my method, which is this one, which goes through that whole process that I described there. Then I'm going to again display the value of this.x from the global context. So let's see what it does. What would you expect it to do? As you notice here, the first one gives us what we expect, a, no big deal there. And the second one, when we call the method here, my method, it returns a. But wait, we assign b to this.x. And why did it do that? Well, we assigned a to it here, but then we assigned b to it. And so it should have returned, you would think should have returned b here. But the fact of the matter is that in this case, this function, since it's not a member of the person method, it is part of the global context. And since it's part of the global context, this in this case is referring to the same global context as this. So this is not what you expect. That is why a lot of times JavaScript programmers will do something tricky like this instead. So they'll assign that into this, and then they'll assign that into B, and then it would do what we expect. So if we were to run that, now you get what you expect because now the method is A, and of course the other one is going to continue to be A, and we didn't change it. So that is one trick that is used. But there are other things that you can actually do now with arrow functions and such, because using functional style programming where things don't change or you use constant, all these different things. So you have pure functions, but we're not going to get into that. Just be aware that this is not always this, it's context sensitive. So this is being declared in the global context, even though it's part of the member function, it still belongs on the outside. The method this. Another thing about this is that, let's take a look at something like this. Let's say that I had another function, or let's call it a method. So method B, and we just say get X, for example. Oh, I'm doing this all wrong. So it's get X and it's a function. And so let's say that we want to return X. Well, you may be used to this in your programming language of choice, whether it's Java or C# or C++ or anything like that, and where you don't have to declare this in front of it. You don't have to qualify it. But in JavaScript, it's a little bit different. So let's go ahead and take a look. Let's see what it does. Person get X. Oh wow, it returned A. Oh, and that's because it's part of the global context. That's why it's returning A. So I didn't expect that. But why isn't it returning in the case where 3, let's see, 2 is supposed to be B, because that's the method that is X. It's not returning that. If I change it here, it's going to change it to something else. So let's say that I did this, and it's going to return X. I mean Z. Excuse me, Z. So it's going to return Z, and the reason for that is because you actually need to qualify all your member attributes with this. So you can't even get away with that, because if X didn't exist out here, then we would have even a bigger problem where it may be undefined or something else like that, because it will not even know about it. So for example, if I did this, so, well, not there. Let's see. Okay, just there. So, and you notice that now 3 is undefined, and get X, since it's this, is returning B. But if we just had X, see what it returns. And we actually get an error in this case because X is not even being declared in the global scope. So we get a reference error that X is not even defined, not even undefined. If we were to say this X, then of course we get the X from there. But if we said something else like this Z, it would be undefined because there's no such thing as Z, which is different than the not defined. You notice that Z is also not defined anywhere, but it gives me undefined because I'm qualifying it with this. Whereas if I just say C, it'll give me an error. And it gives me an error. So there you have it. This is not always this. It's not always what you expect in JavaScript. Number 9, objects can be extended at runtime. So what does this mean? In your typical language, you cannot extend an object at runtime. Everything has to be defined up front. The blueprint has to be set up in the class, and all properties, all methods, everything must be there already. But JavaScript's a little bit different, and it can get you in some trouble sometimes, but at other times it may actually be useful. But I think it's best not to do that. Just be aware that it's there. Let's take a look. So let's start by declaring our object. So let's have an object called person. And we can have an empty object, and then we can extend that object and add attributes. So we can give it, for example, and we can also give it attributes. So for example, let's say that instead of doing that, we did something like this. As you can see, you can extend the object, but you're not necessarily extending the class because this is an object literal. There are ways to create an object. Let's say, for example, that you had an object and you didn't declare it this way. Let's say you had a person, and let's use a constructor function. In a constructor function, this you can assign functions. So we can bring this in here. And to make it even better, we can declare something in here. And remember from the last session that I said that this, you can access this. So we can return first name. But keep in mind that we must use the this word to qualify it. So in this case, let's get rid of this. And let's construct our function. So let's just say person equals new person. And so okay. We have undefined. So let's say person equals new person get first name. And we have this. I'm not sure if it's because I used the let keyword. I don't think that's it. It gave me undefined. So let's say bar. Let's see if that changes anything. It's still undefined. I didn't think that was it. Oh, yes, of course. I'm doing this wrong because this, when I do this, this is visible to the function inside of here, but it's not visible as a attribute. I would have to say this dot first name equals Joe, but maybe we don't want to expose our first name. So what we want to do is just use first name instead. So not qualify with first name because that is undefined. So let's take a look. So this is a better way to construct an object. That way you can have, this is sort of behaves like a private field, if you call it that. And you can't access this from the outside. So I couldn't say in this case, for example, this, it would not know what I'm referring to when I say first name. It would give me undefined. But let's say that I did have that object and I wanted to extend it. So I can still extend person after construction. And now I'm extending that property. So I can say get last name. Assuming that I had a last name here. Will that work? Let's try it. And it tells me that last name is not visible, and that's because it's not within. If I'd have to declare it inside of here. So in this case, in order for me to see last name, it would have to be this dot last name in order for me to see it. So let's just say I had this. In that case, I could see last name. And there you can see how I extended it. But once you start extending objects after the fact, then it gets a little trickier because, like you saw earlier, I don't have access necessarily to the things declared within that function, since they were not within that function that this method was declared. So there's a lot more to working with objects in JavaScript, and now with ES6 and ES 2016, you actually have classes, so you can do a lot more with those things. So, but just for now, just know that you can extend an instance, and here I'm extending the instance of the object, but I'm not necessarily modifying the person. If I created a new person, and let's just say that I try to access that last name, it's going to probably give me an error because the new person was not extended. It's not extended at the prototype. You'd have to extend the prototype. So you can look more into prototypes, actually extending the prototype. And as you notice, this is an error because P2 does not know anything about that, because I've actually only extended the instance of that object. So that's number 9, objects can be extended at runtime. Number 10, functions always return a value. So in other languages, you have the keyword void when you don't return a value, and then you actually have to declare the type. Since JavaScript is dynamic and you don't declare the return type, JavaScript also has the capability to always return something. That something may not be what you expect, but by default, it always returns undefined. Let's take a look. In this example, we have the function add, and as you can see, it returns undefined because I do add the numbers, but I'm not returning the value. So in order for me to do that, I'd have to return the value. And so now it actually does what I expect. But what if I had some complex logic, or it's something common that you actually do in other languages? So if you say, for example, if x greater than, let's say, 10, return x plus y. Else if, let's say, x is greater than 5, and let's use the curly braces for consistency. Then let's return x times y. And then let's say we forgot our else, or our default return statement. So we could do this. So if it's greater than 10, which will make it 11, we'll do that. And then we'll do if it's greater than 5. If it's less than 10 but greater than 5, so let's do 4. And let's do something simple like 2. And then let's do something that's actually less than or equal to 5. Actually, this should have been something greater than 5. So let's do 6 times 2. So now we do something that is, let's say, 4 times 2. Okay, so let's see what we get. And you notice I get 17 because the first time it falls into this and it adds 11 plus 6. So the second time around, 6 is not greater than 10, but 6 is greater than 5. So it multiplies 6 times 2, which we get 12. But then we don't have the other conditions, so we forgot them. Let's say we just forgot the other condition and we're not returning a value. So 4 and 2 gives us undefined, not what we expect. So as you can see, this is something that could actually lead to some really obscure bugs at runtime if you don't fully test your code. So just be aware that JavaScript always returns a type, even if that value is undefined. 11. This is a bonus. Semicolons are not required in JavaScript, but there are a few things that you must be aware of. As you may have noticed, in some cases I was not using them, and that's because I forget. Some frameworks and libraries will require you to use semicolons, so it's just best practice to actually use them. But if you choose not to use them for whatever reason, maybe you're working on something else, or maybe you want to be more advanced, semicolons are not required, except when you have multiple statements within the same line. Then you would need a semicolon to separate the two statements. Let's take a look. Let's take this simple function, and let's say that we return a value, and let's just say we return, say for example, 5. As you notice, I haven't used semicolons in either of these cases, so I have create, return 5. So, and actually I need to not return 5, I need to call create. So, no semicolons. Clear this, and let's run it, and I get 5 as expected. But what happens if I return 5 like this? Well, that may not be what we expect. You notice that it returns undefined because JavaScript will automatically assume that that is the end of the function, and it does not see that 5. But if I was to do this, let's see what it does then. It still does undefined because it automatically adds the semicolon. But if I was to do something like this, what will it do then? And so in that case, because of the parentheses, it's going to look for the other parentheses and return 5. And the same thing goes for objects. So if you had an object that you were returning, so you're returning an object where x is 5, and notice I don't have the semicolon, I could have it at the end of the return. And in that case, you notice that I have an object return 5. But what happens if I drop my semicolon down? So now it returns undefined because it doesn't see it. It has to see it at the beginning. So they're not required, but for best practice, it is best to use them. And notice that the string literals, the object literals, this is how you declare them, and you've seen them in other sessions earlier in this session, in this lesson. So you would separate them with commas, so comma 7 and so on. So you would separate them with commas. Just keep that in mind because you may make the mistake of using semicolons in that, but you don't need semicolons in that case. So if I was to run this, you can see that if I put a semicolon, I think I'll actually get an error. So there, I get an error. So I need commas. So there you have it. That's the bonus. And thanks for watching. If you enjoyed this video, just make sure you subscribe. Make sure you like it. Give it a thumbs up if you really like it. Enjoy it. Subscribe if you want to get more videos like this in the future. Also, keep in mind that I'm working on a JavaScript course for Udemy, and I will keep you posted. So if you subscribe, chances are that you'll get notified when I create that video, finish that video series, and then you can watch that entire series and more in depth as far as JavaScript is concerned. Thanks for watching.